Hello, welcome back. In this part, we're going to take a look at how we can run our first Hello World program in assembly. Okay, so let us take a look at that. So inside our terminal, we are going to print the working directory. As you can see, we are inside home user, and then we are going to use Nano to create our first Hello World program. Okay, and I'm going to name this file hello.sm. Okay, like that. Okay, then we are now inside our GNU Nano editor. Okay, so from there we are going to start writing our instructions. Okay, so we are going to begin with the section. We are going to begin by creating our segment or section, and it's going to be called, let us create all our sections, but in this part we shall need only 2 sections. Okay, so I told you in assembly we have, in any assembly program, we have 3 sections. Okay, so we have the text section, and we have the BSS section, and then the data sections. Okay, so you can omit out using one of those sections. Okay, so for example, we don't want to use the BSS sections, we only want to use the text section and then the data section. Okay, so they are the only one that we are going to create in this part. Okay, like that. Okay, so inside the dot text section, we are going to declare this one for the linker. Okay, so it's going to be we are declaring the starting point. Okay, so we are going to use the global keyword, and then we are going to start from the main label. Okay, so from there I'm going to go down there, and then I create my main label, and then I use a colon. Okay, and this one is going to tell the linker our entry point. Okay, so from there, below this instruction, so just press, when you press enter, just press tab like that, and then you can write your instructions down. Okay, so for example, we are going to start by moving. We use the move instruction. We use the move mnemonic. Okay, move edx into the length. So we are going to create, so this is going to be the message length. Okay, len is going to be the message length. We are going to create it later. Okay, but let us first create it. Okay, so we are going to have our message. Which is so we use db. Db is like the bytes. Okay, so we are going to be storing bytes in this msg variable. Okay, so we are going to have, so you can use single colons, single quotations, or you can use double quotes. Okay, so let me use double quotes. So we are going to have our message hello world, like that. Okay, like that. So from there we are going to break the line. So to break the line, we use 0x like that. Okay, so this is our dear string. Okay, so from there we are going to determine the length. Okay, the length, and we are going to store that length in the len of variable. Okay, so we are going to set it to, we are going to use the equal keyword, equal, and then we are going to use, so to get the length of our message, we use the equal keyword, and then we can use $sign dash, and then the name of our variable, of our string. Okay, which is msg. Okay, so from there now we can come inside our main label, and then we can use our length, our len variable, and we need to store that length inside the edx register. Okay, so we shall take a look at registers, all of them. Okay, and what they are used for. Okay, in future parts. Okay, so but just know this is called the edx register. Okay, so from there we can now move. We are going to move ecx. We are going to move, let us move our message msg inside into the ecx. Okay, so here we need to provide the message which we are going to write in the standard output. Okay, so from there we are going to move one into ebx. Okay, one into ebx, like that. Okay, and here what we are doing, this one we are providing a file descriptor. Okay, for the standard, or call it the standard output. Okay, so here we need to store one inside the EBX, okay, which is the standard output or the file descriptor that we want to output something in the console. Okay, so from there we can move the EX. We want to move 4. Okay, so if we move 4x into EX, here we are providing a system call number, or call it the system write. Okay, and this one is used for writing in the console. Okay, for outputting something, for writing something. Okay, so from there we can now call the kernel using int 0x8, like that. Okay, so here we are calling the kernel to execute our instructions. Okay, so from there we can now try to exit. Okay, and to exit out of our program, we move 1 into EAX register, and this one is called the system call number. Okay, the system call number, or call it the system the sys exit, okay, or the system exit. Okay, so from there we need to call our kernel. We need to call our kernel using int 0x80, like that. Okay, so this is our program. As you can see, we only have a few lines of code, as you can see. Okay, so there are only 14 lines. Okay, right there, as you can see. Okay, so from there, let us now take a look at how we can run our program. Okay, so let us take a look at how we can compile and link our program. So let us press Ctrl S to save, and then Ctrl X to exit. Okay, to exit. So from there we are going to use the NASM assembler. Okay, so we use the NASM assembler. Let's use the NASM keyword, and then -f, and then elf, and then the name of our program, of our file. It's called hello.asm. Okay, .asm. Okay, so press enter, and if I press dir, okay, as you can see, we have our object, our file. Okay, as you can see, it's right here. Okay, it's called hello.o, like that. Okay, so from there we need to link the object file and create an executable file. Okay, so we are going to create that executable file. So this is called the object file. Okay, so let us now link. Okay, in order to link, we are going to use LD binaries, and then we use -m option, and then elf underscore i386. Okay, like that. And from there you can use -s option, and then -o for the output. So the output, we are going to have we are going to name it hello, and from there we need to provide our object file that we want to link. So it's going to be called hello.o. Okay, like that. So from there we press enter, like that. As you can see, cannot find the entry symbol underscore start. Okay, and we are defaulting to this one. We are defaulting to this one, right? This one here. So this problem, this one here, this error, when this error happens, your program is going to execute. Okay, very well. Okay, but when we try to link, or we try to compile, we're going to get this error because we don't have this entry point. Okay, which is called the underscore start. Okay, and if we go back, okay, let us execute that command again. As you can see, this error is going to persist. Okay, but if we go back, let's go back into our program, and then we try to change main to underscore start. Okay, and then here we use underscore start, like that. We save, and then we exit. Okay, so from there let us go back, and we use NASM, okay, to generate the object code, or the object file. Okay, after generating, we run, we use the LD binaries to link. Okay, and we press enter. As you can see, that problem has gone away. That error is not appearing. Okay, because we used underscore start. Okay, underscore start after writing the global, and we use this label. Okay, this label, so we don't have any problem. And if I press dir, as you can see, we have our executable, okay, file. Okay, our binary, as you can see, it's called hello. And if we type ls-la, like that, and we take a look at it, where is it? It's right here, hello as you can see, we have the execute permission. Okay, so we can execute it. So let us execute it. Let's use ./hello, like that, and then we press enter. So when we press enter, wow, we get hello world, like that. Okay, so congratulations, you have run your first assembly program. Okay, so from there, let us go back. So as you can see, we are now on a new line. Okay, so this one is now on a new line. Okay, so let us go back and we'll remove the other one that I showed you, that I told you is going to move the cursor to the next line. Okay, this one here. So let me remove it like that, and then I save, and then I exit, and then I try to assemble again. After assembling, I try to link. After linking, I try to run. Let me try to run. As you can see, this one is now on the same line. The cursor has not moved to the next line, to the new line. Okay, as you can see. So that's the importance of using 0xa. Okay, so let's try to use this one here. Let us test 0. We save, we exit, and then let us try to assemble, and then we link, and then we run. As you can see, 0 does nothing. Okay, so we can also try to use 0xd. You might find these ones in many programs. Okay, and you wonder what they do. Okay, so 0 does nothing. So let's go back. Nano hello. Okay, and then we try to use, instead of using 0xa, we are going to use 0xd, like that. Try to save, we try to exit, and then we try to, let's try to assemble, and then we try to link. After linking, we try to execute. Wow, after executing, we get nothing. Wow, we get nothing. Okay, so let's try to echo out the exit code. So the exit code is success 1, which means our program has run successfully. Okay, so we should use, let's go back inside our program, nano, and let's combine them, and then let's use 0xd, 0x, this is x. We save, and then we exit. We try to compile, we try to assemble. After assembling, we link. After linking, we execute. As you can see, we get hello world, successful, like that. Okay, so that is it, guys. So thank you in the next part. Thank you if you have subscribed and you have watched the entire video, okay, or the entire part. Okay, so in the next part we shall take a look at other concepts, other assembly concepts. Thank you.